What does musician, composer, sorry, and rock star Beethoven and Drake have in common? So both of them think that they write amazing music, but both of them also needs other people to tell them. Another thing that they have in common is that they have absolutely nothing to do with my talk. So, hello, my name is Yuan Fuyun. I finished a computer engineering degree last year, and I'm currently working in the SARS team in the projects division. And today, I'd just like to walk you through a tiny part of the human journey to code music and play it back. Yeah. So, who here can play an instrument? That's quite a lot of people. I play the piano for my main instrument, and I'm going to assume that there's some people online that can also say that they play instruments, and I'm going to assume they also play piano and ignore them. So regardless of whether you can actually play an instrument or not, I assume that you'd also know that we use sheet music to transcribe it. So that actually allows you to write down the music that you want to play and then have it played at a different place somewhere else, which means that kind of technically sheet music is the first programming language for music, but the compilers were pretty energy inefficient. So one problem so far, I know what you're thinking. I was promised code and music, and we've done like a tiny bit of music, but no actual code. So since everyone knows that HTML is a programming language, allow me to present music XML, which isn't even HTML. So this is actually the standard that was used when people started writing sheet music digitally. And most software packages that write the sheet music can actually write it, export it in this format. Like this one here, it's called MuseScore. And what's nice is they can actually synthesize the music for you and play it back, which means that we do actually now have a compiled language that plays music. But unfortunately, not quite code yet, right? So let's try again. We currently have a way to write something that resembles music in a text editor and have it compile to actually play something. But maybe let's jump in a bit deeper and get to some actual code. So this is updating very slowly. This is Chuck. It's a wonderful piece of software made and maintained by Stanford University. It's just reading off the thing, actually, a programming language for real-time sound synthesis and music creation. And I love this at the top. It's strongly timed because it has to do with music and timing. So I think showing rather than telling is the best operation here. So I'm just going to go ahead and actually open that up. Demo 1. Hopefully that's big enough for everyone to see. But so here we're starting with a sine oscillator, which is going to the DAC of your computer, which for our intents and purposes is just the sound output. Then we're taking a MIDI note, which is, if you can imagine a keyboard, it's just 1 to 88, all the notes on your keyboard. And we're converting it to some frequency that would be. So I think middle C is like 50 and it's 440 hertz, something like that. And we're assigning it to that oscillator that we've made, its frequency. And then we allow a second to pass in Chuck terms, which actually plays the note. So I can actually start up the cute little virtual machine. And I'm hoping, hey, there we go. So that's our little hello world. I wasn't completely sure if that was going to work audio-wise, so that's good. So let's actually go to the next example. If I can open them. I have to open it after I've connected here, otherwise the audio doesn't work. It's really strange because of that virtual machine. So that was a bit loud, actually. So we can actually add a little volume, and we can set that down a tiny bit so that we can actually manage it. And then we can add many notes actually in an array because it's a fully Turing complete programming language. And we're going to iterate over them and let 500 milliseconds pass. And that's going to sound like this. So that's our first, just an octave being played, which is lovely. So let's get the last one up if we want to open some actual music. So here I've gone, and I need to actually make it a tiny bit bigger. There we go. So here I've gone, and I've actually changed the oscillator that we've been using. So this is a triangle oscillator, which does actually, it's like to do with the waveform. It changes the type of sound we have. I have a gain again. I have my whole little array of notes, and I've added an array of durations, which means that now we can actually have different notes at different timings. And I've added at the bottom over here, just a little gap in between notes where you actually turn off the oscillator so that playing the same note twice actually sounds like two notes instead of just an extended one. And that sounds like this. So this is just a tiny bit of the range that you can make with Chuck. So I have, let's just go back to slides. At this point, I was thinking, this is so cool, right? Like you can do so many things with it. Let's cheat and see what other people that can actually do it have actually made. So that gives you things like this. If that wants to play. Oh, that's very soft. Not sure. Maybe I'm gonna actually have to play that one. Sorry, that was supposed to be one big reveal. There we go. That's a bit more impressive. So that's the THX. They call it the deep note, completely recreated using Chuck. So then we have, you can also do this. So this is the Towers of Hanoi. It's a cute little logic puzzle, but the reason we actually care about it here is it's usually used in textbooks and stuff as a wonderful example of recursion. So we can actually check. This is in Python. This is how you would do it there. It's just using a little recursive loop, and it's printing out the answers for how you would move this if you're actually trying to solve it. Then I've snuck in a little Haskell. So that's done with Haskell. It's even shorter, which I like. And then a wonderful example also of PHP, which loves doing things terribly and decided that it's going to go like 3-4 times as big. And it's good because now there's two types of people in the room. One type of people thinking, oh, wow, yeah, that's terrible. I hate PHP. I'm glad we're not working with that. And then a different type of people saying, that's terrible PHP code. But I'm sorry, I'm not going to learn PHP just for this bit. You can blame Mr. Chakraborty for that, who I stole his example from. So it can actually, even though it can do all these nice things, Chuck has recursion. So it can do the same thing. It looks a bit bigger, like after I've done on the PHP, but it's actually longer because it has to set up the audio before it can get started. And that actually sounds like, I'm going to see if it works for this one. But it's probably going to be too soft again, to be honest. So I'll just add it to the actual virtual machine. Thank you for messing up my talk with your little bar. Open, which is actually demo 4. Demo 5? Sorry, I really thought the audio was going to work. Yeah. So this is audio-wise the Towers of Hanoi being played using Chuck, but it's irritating a little bit, so I'm just going to turn that off. And unfortunately, I'm going to have to ruin the next slide since this audio isn't working. And I'm going to have this one as well. So Chuck can do all these cool sound stuff, so it can be used in games. It has a Unity plugin, so you can play things there, but it still has some musical chops, so it can also do this. So this is also lovely recreated in Chuck by some legend on the official Chuck site. So this is part of their examples. So at this point, I was thinking, I might actually have to sign away my soul to get good at this. I don't really want to get a degree while I'm busy learning to make music. Maybe Scratch was onto something, you know? So just like drag and dropping, get some music done. So how about some middle ground? This is called Sonic Pi. So it's actually created by a guy called Sam Aaron, and he uses it to code music live on stage and actually play it. So it's a good middle ground of, I want to make some music now. You know, it doesn't look like C, which is a good thing for me here. So I'm going to open that as well. And this is another one where I actually have to open it in the presentation. Otherwise, for some reason, it doesn't play the sound. Sam Aaron. Right. And what a better hello world that is. I can just say, run. Tiny bit soft. I can actually turn that up in here. That's a bit better. I hope that's okay online. But that's our little hello world example. So we can play a note, and then we can actually, this is now just the notes on your piano itself. So I can switch to like E5. And it's an octave higher. So that'll be all the notes. You can also actually use the numbers, the same MIDI notes that we used for Chuck. Then going on, the only problem that we have is it's actually concurrent, synchronous. So if you don't add sleeps, it'll just play everything at the same time. So I can have a little sequence if I do it like this. And by using different sleeps, obviously, you can have the tune be whatever you want. So then moving up one more, you can also do chords. So obviously, more complex music has chords. So you can play nice things like this, combine them however you want. Writing out large lists of these gets irritating if you're trying to actually write music. So we can also have this play pattern timed. So you give it a few notes, and you can actually also give it the durations, and it'll just loop through the durations going along. I think for this one, I might actually want to just add another one. And you can see at the top with actually using a different synth. So that's the sound samples that it uses. And it has like 100 of them by itself. But if you're musically oriented and you know how MIDI works and you know how samples work, you can load in whatever you want and use that as well. So that will sound like this. So now we're looking at having a bit more sound. Obviously, the notes were overlapping a bit. So we can actually solve that by doing something like this, which I see I'm skipping an example. So I'll just go, if you're doing live music, as the Sam Aaron guy is doing, you can also select these live loops. So this will go around and just live loop, turns out. Sorry, I'm blasting through these a bit quickly. And here we go. So I'm adding a few more things here. So once you have live loops, you can combine multiple live loops so that you can have a bass line, you can have your main tune. And I've added a few things here. The synth defaults changes the sound a bit, so you can have it sound a bit different. You can just fine tune it at the last bit if you want to. And they have this thing called attack duration sustain release, which is for the length of a note. But for all we have to know now is I'm setting them so that it's a bit of a different length. And that sound like this. And it's going to keep doing that forever since we're actually in the live loop at the moment. And some people might have guessed where this is going, but that means that if I want to write a longer song, I can do something like this. So this is the original Tetris theme from olden times. If you don't know that, I'm sorry, missed a lot. But I think it's pretty good. But this is just my attempt. I'm gonna stop that now before it kills us. This is just my attempt to make something, and then obviously again you go look what have people actually made. Lovely things. So I wonder who can tell me what this is. That's Stranger Things, you're right. So this is the intro of Stranger Things recreated using Sonic Pi. And then for our last one, I'm just going to send this out and in my talk by playing this amazing creation that someone made, recreating an old Europop song. Thank you so much.